Chapter 13, question 3 says, classify each of the following monosaccharides as an aldopentose, ketopentose, aldohexose, or ketohexose. So let's unpack a couple of the terms here. The first term is this monosaccharide. So what is that? That is the fundamental unit of sugars. So that's a single sugar. If you imagine carbohydrates as chains that have lots of links, each of these links would be a monosaccharide. And monosaccharides are polyhydroxy aldehydes or ketones. Hydroxy aldehydes or ketones. The hydroxy here is just an OH. That's a hydroxyl group, and so an OH is the hydroxy. Poly just means you have a lot of them. So notice how many OHs there are in these molecules. So many, hence polyhydroxy. The next thing is you either have an aldehyde or a ketone. And so you can notice that in these molecules, aldehydes or ketones, here we have a ketone, carbon double bonded to oxygen, single bonded to carbons on both sides. And here we have a carbon double bonded to oxygen, single bonded to at least one hydrogen. That's an aldehyde. So on the top we have a ketone, on the bottom we have an aldehyde. So monosaccharides, you can recognize them because they'll be molecules that have lots of OHs, and they also will either have an aldehyde or a ketone in them. And those molecules that have those two features are the fundamental building blocks of carbohydrates or sugars. Now these monosaccharides, these fundamental building blocks, can be classified first by whether they have an aldehyde or ketone. If they have an aldehyde, then you give them a prefix aldo. And actually, let me do this. If they are an aldehyde, then you give them the prefix aldo. If they are a ketone, then you give them the prefix keto. Then the number of carbons. So these monosaccharides are polyhydroxyaldehyde or ketones. That definition doesn't tell you how many carbons there are. Then it turns out monosaccharides could have lots of different number of carbons. Now the way that these are categorized, the number of carbons, this has a slightly different prefix system than the IUPAC system for small organic molecules. If you have 3 carbons, then it's going to be given a tri-infix. If it's 4, it'll be tetra. If it's 5, it'll be pent. If it's 6, it'll be hex, and so on. Now, the most common ones here are the 5 and 6 carbons, pent and hex. So that's going to be an infix, and then last but not least, the suffix for these things. The suffix for these monosaccharides is going to be O's, and that just tells you that you have a sugar. Universal suffix for a sugar is O's, O-S-E. Okay, so let's try A. So for A, first do we have an aldehyde or a ketone? And we can see right here that we have a ketone. So you can see right there, we have a ketone. So our prefix is going to be keto. So this is a keto. Next, the number of carbons. We have 1, 2, 3, 4, 5, 6 carbons here. So the infix is going to be hex. And last but not least, this is a polyhydroxy aldehyde or ketone, so it's a sugar, and so it has the suffix -ose. So this is a ketohexose. For B, do we have an aldehyde or ketone? We can see right here a carbon double bonded to oxygen, single bonded to hydrogen. That's an aldehyde. And so the prefix here is going to be aldo. How many carbons do we have in this monosaccharide? 1, 2, 3, 4, 5. That's 5. The prefix for 5 is pent. And then this is a polyhydroxyaldehyde or ketone, so the suffix, it's a sugar, and so the suffix is -ose. So this is an example of an aldopentose.